Hi everyone. So today it's Coach Fred here, just going over another concept on the SAT, and I want us to really think how we can make one concept work for us on this test. There is this one concept that if we can really nail, it can help us with so many problems written so many different ways, and that concept is, if I had a drum roll, I would make those drums go right now. That concept is equivalence. Equivalence. I think we all believe that we know what what equals means, but when we're working with the equivalence on this test, I need to make sure you understand what it means. I like to think of equals. A lot of you will say it means is. It doesn't actually mean just is. I like to think of equals as is the same as. And if I can think about when I have equations or expressions, what the word equivalence means is the same as, it can help me to answer questions. Is the same as doesn't have to look the same. For example, x plus y is the same as 15. That doesn't look the same, right? This doesn't look like this. But we're saying that x plus y and 15 are the same thing. All right, so let's look at what I mean by all of this. So here's a very basic question that you'll see. It'll say, which of the following is equivalent to 3 parentheses x plus 5 minus 6. This is an expression. It's saying, which of these is this expression written differently? So this is really basic because all I have to do is simplify the expression. So what would I do first? I distribute my 3, getting 3x plus 15 minus 6. I would combine the like terms, and that would give me 3x plus 9. Okay, so my answer would be C. Now you could make some mistakes here algebraically. You could forget to distribute the 3 to the 5. Lots of different things that you could do, but when I'm asking you for equivalence, the most basic thing is maybe we can simplify it and see what we're looking at. All right, it can get a little bit more challenging when it says which of the following is equivalent to the expression above. Well, this is a quadratic equation in standard form. So standard form is one way to write in a quadratic, ax squared plus bx plus c. But we have to know that there are equivalent expressions for quadratics. We also have 2 other ways we could write it. We could write it in vertex form, which is a x minus h squared plus k, or we could write it in factored form. Factored form is normally called intercept form because it gives us the x intercepts. I call it factored form so that you remember what you're trying to do. So in looking at this question, it's just saying, how can I write this in a different form? So looking at the answers can help me here. Looking at the answers, I can see they want it in vertex form. All right, so since we're here, let's talk about that. There's 2 ways you could get this into vertex form. You could find the vertex from here, x squared plus 6x plus 4, you could do negative b, x equals negative b over 2a. So standard form, if I want to find the x coordinate of the vertex, I do negative b over 2a, and so that would be negative 6 all over 2 times 1, which gives me negative 3. Okay, so I know the x coordinate is negative 3. To find the y coordinate, you plug in the x. So that would be negative 3 squared plus 6, notice when I plug things in, I'm putting them in parentheses, plus 4. That would give me 9 minus 18 plus 4. That would give me negative 9 plus 4, which is negative 5. So I know that I'm shifting my vertex is negative 3, negative 5. Now, we have to remember that when we are looking at vertex form, the vertex is hk. So in this case, negative 3 would give me a plus or a positive value inside the function. And then the y is just k, so this would be -5. So my answer would have to be B. That's one way of doing it. Another way to put something in vertex form is by completing the square. Completing the square. Okay, so how do we do that? Well, we need an equation to do that. So I'm actually going to make an equation. You know what? Let me erase a little bit so you can see what I'm doing. I'm going to erase all of this and get it out of the way. All right, so to complete the square, I actually have to set up an equation with this, but we can do that. So we would set it equal to 0. We'd bring the constant to the other side. Now remember, we want to make this a perfect square trinomial. So we're going to take half of 6, which is 3, and we're going to square it, which is 9. And whatever we add to this equation on the left, we have to add to this equation on the right. Then this perfect square trinomial, I call it PST if you've been watching my videos, I need to write as the square of a binomial. So it means put it in factored form as the square of a binomial. So remember, it's always the square root of the first and the last terms and the sign of the middle term. In this case, equals 5. And then to get it in vertex form, we want it as an expression all on one side. So I would subtract that 5 over, and there is my answer in vertex form. So again, this idea of equivalence is helping us understand that all of these different forms of equations we have are just the same equation written differently. And I like this because it gives me multiple ways to actually work with different types of equations, in this case, a quadratic. All right, that was a little bit tougher. And even harder. See, we're on number 11 here, and this was a non-calculator question. It says the expression blank, where x is greater than 1 and y is greater than 1, is equivalent to which of the following? Okay, so it means, how can I take this expression and write it in a different way? And look, these are all exponents, and I'm looking at my answers, and my answers are all roots. So it wants us to change it. So how do we change exponents to roots? Well, first we use the laws of exponents, and then we apply the properties of radicals. All right, so in looking at this, I got to play around here. I got some work to do. So I'm going to actually rewrite it so it's bigger and you guys can see it a little bit better. Okay, so we want to simplify it and we want to get it into radical form. Oops, sorry about that. So how am I going to do that? I'm going to change some colors around here because I think it'll be easier. Well, I always say when we're working with the laws of exponents, we want to bring the smaller exponent to the larger and subtract. So working with this x, I see that the -2 is smaller. So I'm going to bring it down to the bottom and subtract the exponents. So x to the 1/3 minus -2, which gives me x to the 1/3 plus 2. Okay, 2 is 6/3, so that's going to give me x to the 7/3. Okay, are we good there? Then I see that on this side, the y to the -1 is smaller. I'm going to bring it up. That's going to give me y to the 1/2 minus -1, which gives me y plus 1. 1 is 2/2, so that gives me y to the 3/2. Okay, so now we got some work to do because that's still not so clear because I need it now in radical form. So how do we convert these to radicals? All right, let me erase what I've done so far so I have some room and you can see it. How am I going to convert those to radicals? Well, it's harder because you got to use the algebra you remember. So just as a review, if I give you x to the 1/2 power, we can write that as the square root of x. X to the 2/3 power would be the cubed root of x squared. And so we can take that idea and remember that it's x p over q. So the qth root of x to the p. All right, so how can I use that? Well, y to the 3 halves would become the square root of y cubed. X to the 7 thirds would become the cubed root of x to the 7th. Oh gosh, Coach Fred, that's still not, I'm still not there, okay? All right, well now I've got to apply the properties of roots. So the square root of y, I'm looking for how many perfect squares. So think of it like this. The square root of y squared times y. And in the cubed root, I'm looking for cubes. So wouldn't x set to the 7th be x cubed times x times x? Again, all those powers would get added together to give me 7, and all these powers get added together to give me 3. Well, the square root of y squared is y. So I'd have a y that would come out of the square root, and I'd be left with that y that's left, this guy, okay? All right, so there I've got y root y, so I'm going to get rid of a. All right, in the bottom, I've got 2x cubed, so I'm going to take out 1. I'm going to take out another, giving me x squared, and I'm going to be left with the cubed root of x. So now I'm looking for that answer, and it looks like my answer then has to be D. That was a little bit harder, but again, the idea of equivalence is just make them look different. Look at it in a different way. Radicals are one way to write these, but we could also write them with exponents. All right. The last one we're going to go over today is it says, which of the following is equivalent to? Okay, again, I'm just looking for an equivalent expression for this. All right, so this is a little bit harder. This is a quadratic divided by a linear term, like a factor, linear factor. And I have to look at the answers here, and I look at these answers, and what you might notice is that these are the answers we'd get when we did long division or synthetic division. And you learned about long division and synthetic division in Algebra 2. I also have a video on it, so feel free to watch that. But in this case, if I want to make an equivalent expression for this, I have to simplify it. And this fraction bar means divide. So I'm going to divide x minus 3 into x squared minus 2x minus 5. All right, so we have to do long division. So long division, we look at this term and this term, and we divide x squared by x. I say to myself, x goes into x squared how many times? And it goes in x times. I line that up with the same term that the same exponent below it. And then I multiply x to x minus 3, which is going to give me x squared minus 3x. Since it's division, I now have to subtract. So that's going to make this negative, this positive. And then I add down. These cancel. I get x minus 5. All right, so now I move on. And I say x goes into x how many times? 1 time. So plus 1. Now I can already get rid of b and a. So then I do 1 times x minus 3, which gives me x minus 3. I subtract, and I get negative 2. So then that's my remainder. So negative 2 gets written over the original divisor. So my answer would be D. Again, when I see equivalent, I first see, can I simplify it? I have the answers. I look at the answers to help me and see if it can tell me how I should simplify it like I just did in the last 2 examples. And sometimes, I don't have one to show you right now, but sometimes I look at the answers, and if they're whole numbers, I actually just plug them in to see if they gave me an equation with an equal sign, if it makes the equation true, because that would be another way I could use equivalence. So let's just review. Equals means is the same as, but it could be written differently and still mean the same thing. All right, guys, hopefully that was helpful and not too confusing. Hopefully If you have questions, please leave them on the YouTube channel and I'll try to get to your answers. Have a great day.